This is the first of three problems we're being asked to integrate an expression, and in this case this is a sum of terms. We can go through and anti-differentiate each term independently. So we'll split up our integral into the two terms, 30x to the 5 and 6x squared. And to actually show this in notation, you can split up the integral using the two integral signs. That's not necessary, but what we'll do is we'll go through and do the anti-differentiation for each part independently. So for the first term, what we'll do is we'll write down the 30, which is the coefficient of the term. And then what we'll do is we'll look at the power of x. It's a 5, so we need to increase that by 1 to make it 6, and divide this whole expression by that new power, which is 6. We add because that's a sign in between the two integrals. In this case, the power of x is a 2, so we increase it by 1 to make it 3, divide by that new power. And of course we add a constant whenever we anti-differentiate for an indefinite integral. We'll now simplify each term, so we get 5x to the 6 plus 2x to the 3 and plus the constant at the end. In our next example, we have an expression where there's an x term on the bottom line, and it's advised the first thing we do is bring that x term to the top whenever we have an x in the denominator, if we can do so. So x to the 4 in the bottom line becomes x to the negative 4. The 3 remains on the bottom because that doesn't have a negative power, so we have x to the negative 4 over 3. We can rewrite that for differentiation and anti-differentiation purposes with the denominator at the front as a fraction. So dividing by 3 becomes the same as multiplying by 1/3. So to anti-differentiate this expression, what we'll do is we'll leave the constant at the front, in this case the 1/3, and then what we'll do is we'll look at the power of x. Now it's a negative 4 as an index. We need to raise that by 1 to become negative 3 and divide by that new power, and then add the constant. Now we can simplify the denominator by multiplying the 3 and the negative 3, and that makes it negative 1/9. Still x to the negative 3 plus a constant. And then what we'll do is we'll tidy up the powers so that the index for the x becomes a positive index, and it's 1 over 9x to the 3 with a negative at the front, and then plus a constant. When dealing with negative powers of x, the question arises, what if it's to the power negative 1? So if we anti-differentiate this expression, we get x to the 0 divided by 0 plus c. And of course dividing by 0 provides no solution. There is a special solution for x to the negative 1, and it does rule out the condition we had before about raising the power and dividing by the new power. It's equal to the natural logarithm of the absolute value of x plus a constant. We'll be checking examples like this in a separate video. Now let's have a look at an example of an integral where we're dealing with a root of some particular expression or function. In this case, we'll look at the square root of a single term. What we need to do is make sure we write this expression as x to a power. So the first thing we'll do is take the x cubed and raise it to, in this case, the power of half. Of course, if we're dealing with a cube root, it would be to the power of a third, or a fourth root, a power of a quarter, etc. So we rewrite our integral as the integral of x cubed all to the power 1/2. From here we can apply an index law. So we multiply the 3 by 1/2, and of course 3 is effectively 3 over 1. So multiplying those two fractions together, we get x to the power 3 on 2. So to integrate this expression, we apply the same rules as before. We have x to the power, now it presently is to the 3 on 2, so we raise it by 1. And I'll write this out in full, so it's 3 on 2 plus 1 divided by that new power, which is 3 on 2 plus 1, and we'll just confirm this fraction to the side to make sure we understand what's going on. So adding 1 is the same as putting that as a fraction, 1 over 1. We need common denominators, so our second fraction becomes 2 over 2, and adding the numerators we get a result of 5 over 2. So we'll just put this work to the side to help us work out the new index. And our solution becomes x to the power 5 on 2 divided by that new power, which is 5 on 2, plus a constant, of course, for an indefinite integral. So tidying that fraction up, we find that on the bottom line we can rewrite 5 over 2 by inverting that fraction and multiplying. So we get 2x to the 5 on 2 divided by 5 plus a constant. We can go a step further because the fraction index can be rewritten such that it's x to the 5 inside a square root, or in other words to the power of half. So our final result is 2, the square root of x to the 5 divided by 5 plus c.